Hi, this is Jeff Heaton. Welcome to Applications of Deep Learning with Washington University. This is Module 2, Python for Machine Learning. In this part, we are going to look at the Pandas data processing framework that we will use throughout this course to bring data into TensorFlow for use for predictive modeling and other things that we'll use that data for. All right, Pandas. I have some more information that you can read about Pandas in the course module information on GitHub. But Pandas is basically a data manipulation framework. It loads data in from CSV files and other locations, and it allows us to manipulate that data and get it ready, do the pre-processing, among other things, that we need to do to get it into the neural network so that the neural network can make predictions. Pandas is used mainly when we're dealing with predictive modeling sort of data. So data that has a number of rows, and we want to use a number of those columns in those rows to make predictions on another column. When we deal with images and natural language processing, we won't use Pandas to get that data. We'll see that we'll have other means to do that. So Pandas. We saw this a little bit in the previous part. We can basically read in a CSV file and print that out. Here I am printing out the data frames, the first data frames of the AutoMPG dataset. This is the dataset that you will use for the assignment for this particular module. I tend to change that assignment every single time, so make sure that you look at what specifically I'm asking you to do. Typically, you will use Pandas to perform some sort of calculation and create another field or some other modification, save the file, and send it in. This shows you how we can use Pandas to do something a little bit more complicated. So what we are doing here is we are reading in the data frame. We strip off any non-numeric values. So that's going to strip off the name and other values that the car data set has that we don't really need to see. Then we're going to get a list of the header columns. We're going to create a list. So this is an empty list. And we're going to loop over all the fields in the headers, and we're going to calculate some basic statistics about it, and we'll print out the fields here. There you can see the results. We have the name, the variance, the mean, and the standard deviation of each. Now, one thing that I very much suggest if you're just getting to familiar with Python and with Pandas is print out intermediate values to really understand what is going on. So if we take this part out at the very end, I'm just going to comment it out. Pound signs are comments in Python. And I run it. Now it's basically doing nothing. But I can print out the data at intermediate steps. So if you're ever curious what some block of code that I give you is really doing, I suggest breaking it down sort of like this. So if I print out just df at this point, so all that we've done is we've taken the data frame and we've gotten rid of anything that is not an integer or a floating point. If we print it, you'll see that the data frame looks similar, but we've got miles per gallon, cylinders, displacement. In fact, let's just print the first part of it so it's even clearer. You'll see that we have miles per gallon, cylinders, displacement, all of those. Whereas if we look up here where we just printed out the whole thing, we have the name. So we basically dropped the name column. The next thing that we're going to do to this is we get a list of the headers. So if we print out the headers that we get there, helps if I give it the right name. You'll see basically all of the headers that we had in that data frame. Now it's with the name subtracted because we're using the data frame that we had just removed anything that's not an int or a float. So you might wonder why I need the list conversion here. If you look at the format of it, you'll see that headers right now is a nice list. So you see the commas there. I can iterate over it. If I don't do that, it won't be iterable, and let's not do that. Let's just print out that put into there. And you'll see I no longer have the commas. It's not a valid list. It's a different type of data form, but it's not something that I can iterate over. Now, basically, what I am doing is I create an empty field, and I append to it. See the curly brace here? I am creating a map, and that map, or that dictionary, it has 4 values, and I am able to loop over all of the fields, get that data frames field, get the mean, get the variance, and get the standard deviation. And this is basically how I just showed how we can combine some very basic statistical capabilities, and we can very quickly run a report and see all of those values, all of the statistic calculations for those fields. Sorting and shuffling is very important because if you're going to slice your data into multiple partitions, like we will do later with cross-validation, you want to make sure that the data are evenly distributed, so that you're truly taking a random sampling. Here I read in the auto MPG data set, and here I have this line commented out. But if you put the random seed in there, you will get consistent randomness, which might sound like a contradiction, but I'll show you why that's important in a moment. Then we do the actual shuffling here, and this line is really just a convenience. So let me show you why each part of this is actually needed. Again, just break the code down and you can see what each individual piece does by itself. First of all, let's see why that random seed is useful. If we run this, notice here we have the Renault Liqueur Deluxe at the top. If we run it again, now it tends to move me around sometimes when it runs. Now we'll see that we have the Chevrolet and the Audi 5000 DS there, the diesel. If we run it again, we have a different, oops, I have to keep moving back up to here so I run the same one. Now we have a different one. Notice if I put this in, we get consistent random results. The Honda Civic is at the top. Run it again, Honda Civic. We are indeed changing the order of these, because if we comment out this and this, now we're no longer shuffling. So this is the original order. The Chevy Malibu is at the top, but we are consistently ordering it. What's good about this is it's reproducible. We've randomized it, so we are truly getting our random sample that we need so that we can evaluate this. But every time we run it, we're going to get the same ordering. So that can be very important to do, because you might take a random sample, then you change something later on in your program, you have to rerun the whole thing. You want to make sure that you're dealing with the same slices of data that you had before. Okay, so let's see if we remove the reset index. Notice these row numbers, which are important when you access this like an array. Here you'll see that the row indexes have changed. This is because we shuffled it. This Honda Civic used to be at position 198. Now it's at the beginning. But it retains, without this re-index, it retains its original index. In some cases, that can be useful. You can look back and see where it originally came from. I find it tends to confuse other code that I use sometimes that will use these indexes. So I simply put this in so that the index is reset. For anything you do in this course, you should probably use it all in exactly this format for your random shuffling. You might want to sort the data and get a particular value. So here we're going to sort the data. We're going to sort it by name, ascending true. So ascending, just normal sorting order that you would think of. And then I'm going to print out the first car. If you want to access your data by index, you should use the iloc property. Here we say that we are wanting the name. If you just did name by itself, it would give you just a vector of all of the car names. And iloc 0 just means you want the first car. So you're printing out the first car is, and this is the car that comes first in alphabetical order. If you run it, you see those results. If I comment these two out, you can break it down and again see what's going on. If you print df name, so just the first part of this, you see that you basically get all of the, you get almost a vector of all of the car names. If you say 0, then you just want the first one. And that gets you the alphabetically first car sort. I'm sorry, don't use 0, use iloc. I was thinking that is not the first one. So you have to use iloc, so you're getting them by that sorted list that you had. Otherwise, you just get the first one in the list, independent of your sorting. And if you just print out the entire data frame, even though you've done the sort, you'll see that same sort of phenomenon that we had there, where the indexing, it's showing you the original index. So car 96, and it's not showing you the name, it's down there. The AMC ambassador becomes the first car in the list, now that it's sorted. Saving a data frame is important because you will submit the CSV output of your data frame for grading for your assignments. So this is very important that you understand how this works. We saw this already in the data section, or in the part previous to this where we looked at handling data. What we are doing here is we are essentially we are performing a random shuffle of it, and then we are saving it to the CSV. So we're writing it to the miles per gallon shuffled using the original miles per gallon. If I had asked you for the assignment, I don't do this, but if I had asked you to shuffle it and just give me the shuffled data set back, this would be what you would have. So let's see how to create calculated fields. This is often called feature engineering. You will create additional sort of calculated values that you will save into the data set. Here, what we're going to do is we're going to basically create the file name read. We're going to get the auto miles per gallon, and we're going to convert the weight that is in normal imperial measurements, so pounds, to kilograms. Now, to convert a mass in pounds into kilograms, you use this fairly simple equation. Here, we're going to add another column. So anytime you want to add another column, this is a very good way to do this in Pandas, df.insert. That means that we are going to insert the new column after column 1. Now, column 1 is not the first column. Column 0 is the first column. So we're going to insert it. It'll end up right at the 1 location. That would be 0. That is 1. and we're going to name it weight in kilograms, and it is going to basically be the DF weight times that. And we're going to convert it to an integer type. Otherwise, you have these big, long floating point numbers that give you the very precise weight in kilograms. But these weights in pounds almost certainly have decimal places. I'm sure these were rounded off. I doubt the car weighs exactly 3,504. So if we run that and see that, let me not print out the data frame and show you a few pieces of what's going on here. If we just print out DF weight, you will have the weights just of the cars. We can multiply these. We can multiply these by, say, 0.1. Now we would have a tenth of these. And notice you have the trailing decimal places. We can do this part of it and convert them into kilograms. This causes, see, you have the trailing decimal places. All we're going to do there now is convert it to an integer. And you can see we have that conversion to kilograms, and then we just take that and insert it into the data frame at the correct position for a weight in kilograms. And this gives you the result that we were previously looking at. So we've added a column. If you need to add a column with a particular calculation for the assignment for this module, that is probably pretty similar to what you'll be doing. So field transformation and preprocessing. A common technique that you will use is something called a z-score. So a z-score is essentially how many standard deviations, plus or minus, are you from the mean or the average of the data set. Here, what we're going to do is we're going to convert the miles per gallon into standardized z-scores. One of the problems with non-standardized data is it's hard to look at a value just in isolation and tell if it's particularly good. Like if we look at this weight, is that a good weight for a car or a bad weight? Just looking at that weight alone, it's hard to tell because you don't see these others. Now looking down, I see, okay, this is actually, there are weights that are lower, there are weights that are higher. If we convert the miles per gallon, we can get an idea real quick just from the miles per gallon field. We can see this one is a z-score of negative 0.7. So that means it's pretty good. It is actually almost a standard deviation below the miles per gallon. Some of these other ones will have higher values. Like this car is really not particularly good. It has actually miles per gallon, you're shooting for higher values. So this would be a more favorable miles per gallon. You're getting more miles per gallon. This car up here, these ones with negatives, they are not getting quite as many miles per gallon. So they're lower overall. This one would be a little over a standard deviation below the mean. The way that you do that is there's a nice function that we get from SciPy, Scientific Python, that will take your entire miles per gallon row and convert it into z-scores, and then we simply add it in we replace the existing miles per gallon. So we're not adding a new field, we're replacing the previous miles per gallon. This is important often to do because you don't want to you may not want your old field in there. Usually if you're trying to predict something and you transform one of your fields, you don't want both of them in there because now you're duplicating the data in some way. Missing values. So if you look at this data that we're printing out, the horsepower, if we scroll down, we'll actually see a missing value, not a number. Sometimes NaN, sometimes null. We would probably like to get rid of that. So what we're doing here is we're creating our file name. We're going to read the auto MPG. We're going to pull out the horsepower and get the median for it. And then we're going to fill the NAs with that median. So if we add in a few print statements, print median, and at the very end I print horsepower has NA at the end, that lets us know that we have successfully gotten rid of it. But if we put that in up there, we'll see the before and after because we haven't changed it. So now we can run this and we'll get a little bit more data. Horsepower has NA, true. That's the median horsepower. And then we replace it. So any place where it's null, we put that in. This is very important for some of the assignments later on. Concatenating rows and columns. So there's two ways that you can do this. If you have two data frames, you can take the data frames and you can essentially attach them so that they're one on top of each other or so that they're side by side. If you take these two data frames and you put them one on top of each other, the rows will be equal to the sum of the rows of the two. If you put them side by side, the columns will increase, but the rows will stay the same. So what we are doing here is I am reading in the auto MPG. I'm extracting the horsepower field and the name, and I'm literally rebuilding a new data frame that has just those two. This is a very good way to prune out extraneous fields that you might not need. So I have these two vectors of, if I printed those out, that would just be a list of all the horsepower, a list of all the names. I call Pandas Concatenate, and I pass those two in, and I basically get them side by side. So now I have just the name and the horsepower. Notice the axis. With axis 1, that means that you're putting the columns side by side, which might be what you want. In this case, you're rebuilding it, so you want to put them side by side, which is what we're doing here. The rows in the miles per gallon data set is not that big. It's 398 rows, and that's what the original CSV has. So we did not change the row. We just put two columns next to each other. If we do it with axis equals 0, we do PD concat. And by the way, axis equals 0, it defaults to 0. So that's why we don't see an axis there. Now look how many rows we've got. We have 796. What we ended up doing is probably not what you would want, but this first column is the name. Then we attach the second length, or the second series, which was the horsepower. So we essentially, the first column is both the name, and then when you get down to this other one that we just attached onto the end, this one had the name, this one had the horsepower, so we just slammed them into each other. You probably won't want to do that. Usually you want the same columns when you're concatenating by row. All right, so that is the overview of Pandas. I have some additional supplemental information for Pandas on my website. I also suggest Pandas is great if you're trying to do something specific, like say, how do I drop a column in Pandas? Just go to Google and search Pandas drop column, and you will see all sorts of information, usually on Stack Overflow, that will show you how to do that. The next part for this module will look more at machine learning with Pandas and scikit-learn as well.